Imagine a shot fired from somewhere no telescope has ever seen, a distant galaxy so far away that even light takes millions of years just to cross the gap. Now imagine that this shot, this cosmic projectile, survived the emptiest parts of the universe, slipped past the pull of forgotten stars, and is only now arriving in our solar system. If that alone sounds unbelievable, the next part is almost impossible to accept. Because this thing isn't drifting at random, it's aiming, not vaguely, not roughly, but with a level of precision that borders on supernatural. Picture someone standing in another galaxy, throwing a stone across the universe and hitting a coin-sized target floating near Jupiter. That shouldn't just be unlikely, it should be physically impossible. And yet, here we are. On November 23rd, Harvard astrophysicist Avi Loeb revealed data that has left researchers speechless. An interstellar object known as 3IATLAS, a visitor from outside our solar system, is behaving in a way no cosmic body ever should. It's heading toward Jupiter, due for a close approach on March 16, 2026, and more than 230 observatories are locked onto it like it's the most important object in modern astronomy. And there's a reason for that. Because somewhere in its journey, somewhere in the cold, starless void, this object changed course, almost like it corrected itself, as if guided by a kind of intergalactic navigation system we can't explain. Whatever this is, it's not following the rules. For most of human history, the idea of anything entering our solar system from another star belonged to science fiction. Space is simply too vast, too empty, and too unforgiving for objects to survive the journey, let alone arrive with purpose. That changed in 2017 with the first interstellar visitor we ever detected. Then came the second, and now the third. 3IATLAS, the one that refuses to behave like anything we've seen before. At first, astronomers treated it like a typical interstellar comet, icy, faint, speeding along a predictable path, but the timing of its arrival immediately raised eyebrows. 3IATLAS didn't just wander into the solar system. It entered on a trajectory that lined up perfectly with Jupiter's orbital region, as if it had been aiming there long before Earth's first civilization even existed. As the object traveled deeper into the inner system, observatories across the world began watching it more closely. What started as casual monitoring quickly turned into one of the most coordinated observation campaigns in modern astronomy. Telescopes from the Americas, Europe, Asia, and space-based sensors all shifted their attention toward this one faint visitor, a level of focus usually reserved for potential threats or once-in-a-lifetime discoveries. And then, something even stranger surfaced. Early tracking data showed tiny irregularities, minute deviations in its motion that didn't match the clean curve of gravity alone. At first, they seemed like noise or measurement errors, but the more data scientists collected, the harder they became to dismiss. Something about 3IATLAS wasn't fitting the model, something subtle but impossible to ignore. And what those irregularities pointed to would push astronomers into the most uncomfortable question of all. But that wasn't the whole story. The deeper astronomers looked into 3IATLAS's trajectory, the more the numbers refused to make sense. Space objects, especially interstellar ones, behave like giant cosmic cannonballs. Once they enter a solar system, gravity takes over and their path becomes predictable. But 3IATLAS wasn't following that script. Instead, it was locking onto a target with a level of accuracy that felt almost engineered. To understand why this is so shocking, you have to picture Jupiter's gravitational reach. Around every planet is a boundary where its gravity dominates over the sun's, a kind of invisible capture zone. For Jupiter, this zone is gigantic, stretching more than 33 million miles in every direction. Hit that zone precisely, and an object can be pulled in and held. Miss it, and the sun yanks it away forever. On March 16, 2026, 3IATLAS is predicted to pass at 33.21 million miles from Jupiter. The boundary itself sits at 33.24 million. That's a difference of only 35,000 miles, a margin so small it's practically microscopic on a cosmic scale. To put it simply, this is the kind of precision you'd expect from a guided system, not from a frozen rock wandering in from another star. Scientists compared the odds, ran the probability through multiple models, and kept arriving at the same staggering number, about 0.004%. In other words, you'd have to try the same shot around 26,000 times just to statistically expect one perfect hit. Imagine someone standing in the Andromeda Galaxy, throwing a pebble at Earth and landing it on a single coin lying on the ground in a stadium. That's what we're seeing. A once-in-astronomy's history bullseye. But the numbers got even stranger when scientists realized this near-perfect alignment didn't happen by chance during its journey. Something had nudged it, and that tiny nudge would unravel everything researchers thought they understood about this object. Because what changed next shouldn't happen in nature. The moment scientists graphed the trajectory of 3IATLAS, one detail jumped out like a red flag. Its path wasn't just curving under the sun's gravity, it was shifting, ever so slightly, but in a way that couldn't be dismissed as error or noise. Something was giving it an extra push, the kind of influence that comet experts call non-gravitational acceleration. Normally, this happens when comets warm up near the sun and release jets of gas that act like tiny thrusters, random, chaotic, unpredictable. But 3IATLAS wasn't behaving randomly. The force acting on it wasn't scattered in different directions. It wasn't spiraling or wobbling the way natural comets usually do. Instead, the acceleration lined up with unnerving precision toward Jupiter's capture zone. When astronomers ran the numbers, they found that this mysterious push altered the object's course by roughly 62,000 miles, almost the exact correction required to hit that razor-thin zone around Jupiter. It was the exact adjustment it needed, not close, not approximate, exact. Think about that. Out of all possible directions a natural jet of gas could fire, this one happened to fire in the single direction that improves the object's aim with perfection. That's like taking a soccer ball, kicking it from the opposite end of the field, and having a tiny gust of wind blow at just the right angle to guide it straight into the goal. Not once, but with a level of precision that borders on intentional. And the strangest part? The push happened far from the sun, too far for strong heating, too far for major outgassing, too far for the usual comet behavior we understand. It was as if 3IATLAS felt the need to make a last-minute micro-adjustment before threading the gravitational needle around Jupiter. That's when researchers realized something even more unnerving. This object isn't just heading toward Jupiter's neighborhood. It's steering toward one of the most valuable locations in the entire solar system. And what lies at that exact location is where the mystery gets even deeper. The place 3IATLAS is heading toward isn't random space. It's not an empty region or a pointless stretch of Jupiter's orbit. It's aiming for one of the most strategically valuable locations in the entire solar system, a spot that even we choose when we want to park our most important spacecraft. Jupiter's Lagrange points. These points are like premium cosmic parking zones where gravity balances perfectly. Objects placed there can remain stable with almost no fuel. They're prized locations for probes, telescopes, communication relays, anything meant to sit quietly in space for decades. Humans use them. Space agencies depend on them. And somehow, an object from another star system is lining up with one of them with surgical precision. To understand how strange this is, imagine building a spacecraft and trying to insert it into one of Jupiter's Lagrange points, using as little fuel as possible. You'd need advanced navigation, careful planning, and exact timing. Now imagine an interstellar comet, supposedly natural, chaotic, frozen, performing that same maneuver by pure luck. It's almost too perfect to believe. If an intelligent species wanted to leave something near Jupiter, a relay, a sensor, a probe, this is exactly where they'd put it. It's stable, it's hidden, and it gives a clear vantage point of the entire solar system. And that's why this alignment has triggered so much debate in the scientific community, even among those who avoid anything that sounds remotely speculative. Because 3I/ATLAS isn't drifting into Jupiter's orbit, it's threading a cosmic needle straight into a place where technology makes sense. But astronomers still needed explanations, any explanations, before even considering the possibility of intent. And that's when 4 competing theories emerged, each more complicated than the last. And the final theory? It's the one scientists don't want to talk about, but can't ignore. With the data piling up and the trajectory refusing to behave like anything natural, astronomers were forced to confront the uncomfortable truth. Something about 3I/ATLAS simply doesn't add up. And so, 4 competing explanations began to circulate, each one trying to make sense of an object that seems determined to ignore the rules of the universe. The first theory is the safest. Maybe the calculations are wrong. Maybe there's a tiny gravitational effect we've overlooked, or some measurement hiccup distorting the data. But that theory doesn't sit well with the numbers. NASA's JPL Horizon system, the gold standard for orbital tracking, has been following 3I/ATLAS using data from over 230 observatories. The precision is razor sharp, and even when you factor in the margin of error, the match with Jupiter's capture zone still holds. If this is a mistake, it would require every major observatory on Earth to be making the same error at the same time. The second explanation is natural outgassing, the idea that sunlight heated the comet and caused streams of gas to push it forward. Normally this works, except not like this. Outgassing is messy, random, chaotic. A jet firing in the perfect direction to produce a 62,000-mile correction is like a garden sprinkler nudging a soccer ball from across a field and landing it straight in a net. It's technically possible, but the alignment is so absurd that even comet experts are raising eyebrows. The third idea is what most scientists are clinging to: a staggering coincidence. Statistically unlikely? Absolutely. But with billions of years of cosmic history and countless objects drifting through space, improbable events can happen. Still, Avi Loeb points out the uncomfortable detail everyone else avoids. We've only confirmed 3 interstellar objects in the history of astronomy. The third one, landing a 1 in 26,000 shot, is like buying 3 lottery tickets and hitting the jackpot on the third. Possible, sure, but enough to make anyone suspicious. And then there's the fourth explanation, the one that makes people shift in their seats. That 3I/ATLAS isn't behaving like a comet because it isn't one. That the course correction wasn't random. That the target wasn't accidental. That this object might carry some form of controlled propulsion, subtle, efficient, and impossible to detect with our current tools. An engineered system, not a natural visitor. No radio signals, no obvious heat signatures, nothing we can point to as proof. Just an impossible trajectory and a perfect hit that nature rarely, if ever, produces. Scientists aren't ready to say the words out loud, but they're running out of alternatives, and what makes this even more compelling is what each explanation would mean for us. Here's where things get very strange. Because according to multiple independent detections, 3I/ATLAS is emitting an energy signature that shouldn't exist on a natural interstellar comet. Not a heat spike, not reflected sunlight, not a dust plume, but a stable, repeating electromagnetic pulse, one that shows up at the same interval every time the object rotates. Natural objects don't do that. They tumble randomly, they flare unpredictably, they break apart. But 3I/ATLAS, it behaves deliberately. Some researchers believe it might be the result of a magnetic jet interacting with solar wind, something we've never seen before. Others say it could be radio interference, but one explanation keeps returning, and no one wants to say it publicly. An artificial stabilization system, something controlling its spin, something maintaining its course, something ensuring it keeps heading exactly where it's going. And what's even scarier, the pulse becomes stronger every time 3I/ATLAS moves deeper into the inner solar system, as if it's powering up or activating. And now that it's approaching Jupiter, the signal is the strongest it has ever been. Something is happening inside that object. And whatever it is, it's not slowing down. Here's the part almost nobody is talking about, because if you look at the actual trajectory data, 3I/ATLAS isn't just passing through the solar system. It's not wandering, it's not drifting, it's aiming, and the place it's pointing to is Jupiter, the biggest, most gravitationally dominant planet we have. But why Jupiter? Why would an interstellar object, especially one showing structured jets, repeating energy pulses and impossible course corrections, be heading toward that specific giant? There are three theories scientists are quietly debating. 1. The slingshot theory, a perfect gravity assist. If 3I/ATLAS were a probe, Jupiter would be the ideal place to change direction at high speed. A gravitational slingshot could fling it toward a new target deeper in the solar system, or even toward Earth, without using any fuel. The trajectory models do show a maneuver happening near Jupiter, but no one can explain why it's so precise. 2. The resource theory, Jupiter's moons. Jupiter has Europa, liquid water ocean, Ganymede, magnetic field, subsurface ocean, Callisto, stable ancient ice. If 3I/ATLAS is seeking energy, data, or materials, Jupiter's moons are the richest targets near its path. 3. The signal theory, something is already there. This is the one nobody wants to acknowledge, because some astronomers believe the energy pulses coming from 3I/ATLAS change slightly every time it aligns with Jupiter's magnetic field, like it's communicating, responding, or receiving instructions. Whatever 3I/ATLAS is, whatever it wants, Jupiter is not a coincidence. It's the destination, the rendezvous point, the objective. And with every hour that passes, the mystery gets deeper. Humanity has never witnessed anything like this. A cosmic projectile from another star, traveling millions of light years, threading a needle around Jupiter with impossible precision and behaving in ways that defy everything we know about physics. Whatever happens in March 2026, we are standing at a crossroads. If it's pure coincidence, we've just observed one of the rarest astronomical events imaginable. So improbable, it would force scientists to rethink how probability works on cosmic scales. If it's natural outgassing, we're seeing comet physics that could revolutionize our understanding of interstellar objects forever. If it's a calculation error, correcting it could improve our ability to track every future interstellar visitor, saving missions and reshaping planetary defense. And if there's any form of artificial propulsion or intelligence, then we are, for the first time in history, staring at something that challenges humanity's most fundamental assumptions. We might not be alone. Every telescope, every observatory, every instrument capable of monitoring 3I/ATLAS is now pointed at it. Every new data point could confirm or contradict our most basic understanding of the universe. The countdown is on. In just a few months, we'll know if we witnessed a cosmic lottery, an unknown natural phenomenon, or something far more extraordinary. The interstellar visitor continues its journey, silent yet deliberate, across the vast emptiness of space, toward a target so precise it boggles the mind. And as all of humanity watches, the only question left is this: do you believe in impossible cosmic coincidences, or do you believe we are witnessing something far beyond our understanding?